Section 2.3 on polynomial and synthetic division. So before we get into how to divide polynomials, I'm going to remind you about something you learned in elementary school, long division. So we're going to use the process that we learned for long division and actually apply that to polynomial division as well. So let's start with like 512 divided by 11. So first you would see it does 11 go into 5. Obviously not. So then you would try, okay, does 11 go into 51? Okay, well 11 will go into 51 about 4 times. If I put 5, that would be too much. Then you multiply the 4 times the 11 on the left-hand side. So 4 times 11 is 44. And then you would draw the line and subtract these two numbers. So 51 minus 44 is 7. Then you would bring down the next number, the 2, and you try to see how many times 11 goes into 72. Well, it's going to go about 6 times. It won't go 7 times. So 6 times 11 is 66. We draw the line, change the sign. 72 minus 66 is 6 again. Now I'm out of numbers to bring down. There was a point that you learned first that this is the remainder. It doesn't go in evenly, so we have a remainder. So we would write something like 46 remainder 6 or plus 11 over 6. Then as you advanced in your long division, you would actually bring down some extra zeros and you would continue the decimal. And if I continue doing long division, I would get something like 46.54 repeating. Okay, so we're just using the process of long division to help us divide polynomials. So let's look at a polynomial x squared plus 4x plus 4 being divided by x plus 2. We're going to use the same process for long division. So first I want to look at x times what equals x squared, or x goes into x squared how many times evenly. So I know that x times x equals x squared. So once I put the term on the top, I have to multiply x times everything on the left-hand side. So x times x we know is x squared. X times 2 is 2x. So it's going to be x squared plus 2x. Then I draw the line and I change all the signs. Not just the first term, the x squared, but everything that I wrote down I have to change their signs. So you might want to do it bold, you might want to erase the old signs, put new signs, or in a different color, however it works for you. So then I just add straight down. Well, x squareds are going to cancel out. Then I have 4x minus 2x is 2x. Then I'm going to bring the next term down, which is the 4. So now I want to see x goes into 2x how many times? Or x times what equals 2x? Well, that's going to be a 2. So I put a 2 up top. Then I multiply back. 2 times x is 2x. 2 times 2 is 4. We're going to draw the line, change all the signs. So notice our 2 x's are going to cancel and our 4's actually cancel. So we have a remainder of 0. So x plus 2 is our answer when we divide these two polynomials. It's the same thing as saying if I factored x squared plus 4x plus 4, x plus 2 times x plus 2 are the factors. Okay, so let's look at some more difficult examples of long division or polynomial division. So here we have 6x cubed minus 19x squared plus 16x minus 4 being divided by x minus 2. So when it's written out like this, we got to figure out, okay, what goes underneath the division symbol and what goes on the outside. Well, the first term is what goes underneath. And then whatever you're dividing by is what goes on the outside. So same process here. We're going to start with the x and the 6x cubed. I want to know x times what equals 6x cubed. So x times 6x squared will be 6x cubed. Then I have to multiply back. 6x squared times both terms on the outside. So that's going to give me 6x cubed minus 12x squared. I'm going to draw the line, change all the signs. So again, you're going to notice that your first term is going to cancel out. That should always happen if you're doing this correctly. So the x cubes cancel. Negative 19x squared plus 12x squared is negative 7x squared. I'm going to bring all the terms down, not just the 16x. I'm going to bring everything down. If I didn't bring the negative 4 down as I'm working the problem, I might forget about it. So if I bring it down every time, then it's not forgotten. It's going to stay. Every time we multiply back, we know what we need. Okay, so again, x times what equals negative 7x squared. So that's going to be negative 7x. Multiply back. Negative 7 times x is negative 7x squared. Negative 7x times negative 2 is going to be plus 14x. We're going to draw the line, change all the signs. So again, our x squareds cancel. 16x minus 14x is 2x, and then I bring down my negative 4. So then x times what equals 2x? Well, x times 2 equals 2x. So I multiply the 2, so it's going to be 2x minus 4. Draw the line, change all the signs. Notice here, we have nothing left, 0 remainder. There's nothing left to bring down, so we're done. What this means is x minus 2 times 6x squared minus 7x plus 2 is exactly the polynomial that's inside the division symbol. It goes evenly, so there's no leftovers. Okay, so let's look at a different one. So notice in this problem, I have a polynomial divided by another polynomial, or in this case, a trinomial divided by a trinomial. The last problem, example 1, we were dividing by a binomial. So whatever's on top is what goes inside. Also notice that I'm missing some terms here. It jumps from x to the 4th to x squared, and then to the constant term. So anytime you're missing terms in the polynomial, you need to plug in a 0 for those terms. And this is what I mean. On the inside of the division symbol, I'm going to put x to the 4th plus 0x cubes plus 3x squared plus 0 x's plus 1. You're going to see in a minute that if I didn't put those placeholders in, then things wouldn't line up in our problem and we might add incorrect terms together. On the outside, x squared minus 2x plus 3. So, don't worry about all the extra stuff. We're just comparing the first two terms of the outside and the inside. So I want to know x squared times what equals x to the 4th. Well, that's going to be x squared. Now I multiply x squared times all three terms on the outside. So this is going to be x squared minus 2x cubed plus 3x squared. I'm going to draw the line, change all the signs. So my x to the 4ths cancel. Notice I have 0x cubes plus 2x cubes. If I hadn't put the 0x cubed there, then it would be in line with 3x squared and 2x cubed. Well, those terms aren't like terms. So we would try to combine them together and we can't. So it's easier when everything lines up and stacks on top of each other. Okay, so when I add here, I'm actually going to get 2x cubed plus 0x squareds, they cancel. Bring everything else down, 0x plus 1. And I know it's tempting just to leave out the zeros, but we have to have them in place. Okay, so now x squared times what equals 2x cubed. So that's going to be 2x. So I multiply 2x times everything on the outside. That's going to give me 2x cubed minus 4x squared plus 6x. Draw the line, change all the signs. Notice my x cubes are going to cancel. I'm going to have 4x squared, negative 6x, and then I bring down my 1. So again, x squared times what equals 4x squared? That's going to be plus 4. So I multiply 4 times everything on the left. That's going to be 4x squared minus 8x plus 12. Draw the line, change all the signs. My x squareds cancel. I have 2x minus 11. Then I want to know x squared times what equals 2x? Well, there's nothing I can multiply x squared by to get a 2x because it has a lesser exponent. So this is actually our remainder. So when we write our remainder, you're going to add it to the end of your answer and then put it over whatever you were dividing by originally. So this is going to be plus 2x minus 11 all over x squared minus 2x plus 3. So it's not pretty, but that's because it doesn't divide evenly. Not all the time are they going to divide evenly. Okay, so you can see with long division, there's a lot of places that you can make mistakes. If you don't change signs, you don't put placeholders, you can't add, subtract, multiply, or divide. All of those things can be a factor. So we're going to look at another type of division called synthetic division that makes things easier for us. But with synthetic division, it doesn't work all the time. We can't use it on this example too. We can only use synthetic division when we are dividing by a binomial. So on example 3, notice I have a polynomial being divided by a binomial. Synthetic division only works with binomials. Okay, so I have 3x cubed minus 17x squared plus 15x minus 25 being divided by x minus 5. So for synthetic division, we're going to start by setting what we're dividing by equal to 0. So that's x minus 5 equals 0. And I'm going to solve for x. So we know that x equals 5. So when we set up our problem for synthetic division, it's going to look a little bit different. We're going to put a 5 on the outside of this new division symbol. Okay, I'm going to take the coefficients of the polynomial that I'm dividing into inside this new division symbol, and I'm going to leave one row of space below those numbers. So 3x squared minus 17x, or 3x cubed minus 17x squared plus 15x minus 25. I'm just putting those coefficients, 3, negative 17, 15, negative 25. So the purpose of synthetic division is to have less fuss and less chaos going on. So we're just dropping out all those variables and just concentrating on the numbers. Okay, so with synthetic division, we're going to start by bringing the first term straight down. So 3 in this case comes straight down. Then we're going to multiply the number underneath the line times the number on the outside. So 3 times 5 is 15, and we write it in the next spot. So then negative 17 plus 15 is negative 2. Notice I didn't have to change any signs. I'm just keeping whatever I multiplied by, I put it in the next spot. And then I add straight down. So now negative 2 times 5 is negative 10. It goes in the next spot. And I add 15 and negative 10 together, and I get positive 5. I multiply 5 times 5, and that equals 25. So then negative 25 plus 25 equals 0. So the last number is always going to be your remainder. And when we have a 0 remainder, that makes life easy for us. We're not always going to have a 0 remainder. So how do I write my answer? Well, when we're dividing an x cubed by an x, you're always going to reduce by 1 power. So anytime we're doing these problems, if you started with an x cubed, your answer is going to be an x squared to start with. If you started with an x to the 4th, then you're going to jump down to an x cubed. It's always 1 less than the polynomial you started with. So our answer is going to be 3x squared minus 2x plus 5. What that means is if I multiplied 3x squared minus 2x plus 5 times x minus 5, then I would get that original polynomial that I started with. Okay, so this one was nice because we had a remainder of 0. So let's see what happens when we don't have a remainder of 0. So example 4, we're supposed to divide 5x cubed minus 6x squared plus 8 by x minus 4. So you start by setting what you're dividing by equal to 0. So x minus 4 equals 0. So that means x equals 4. It's always just going to be the opposite sign. Okay, so I put my coefficients of my polynomial on the inside. Now notice I have an extra number here. In my polynomial that goes on the inside, I go x cubed, x squared, I don't have any x's, and then I have a constant term. So I have to put a 0 placeholder in for anything that I'm missing. Just like when we did long division, you have to have that placeholder in there to make things work out correctly. So we're going to bring down the first number. 5 goes straight down. Multiply 5 times 4, that's 20. Negative 6 plus 20 is 14. 14 times 4 is 56. 0 plus 56 is 56. 56 times 4 is 224. 224 plus 8 is 232. So you can see real fast, you could tell that, hey, this is not going to get me a 0 on the end. This is not going to have a remainder of 0. For what we're doing right now, that's okay. We're not looking for a remainder of 0. Later on in the chapter, it will be important that we have that 0 there. So when we write our answer, we start with one less exponent. So this is going to be 5x squared plus 14x plus 56. And then I take my remainder and put it over what I was dividing by. So plus 232 over, I was dividing by x minus 4.